Reviewing again on our mixed fractions and numbers, we're going to do a bunch of word problems to try to get you guys seeing these. One thing we're adding today that actually can be very beneficial when you're doing these division problems is we're adding in some models. So we're going to go back to the K diagrams we started the year with the ratios and rates. You're going to see that these can actually really help you on these types of problems because you can visualize what's happening and make sure you're setting your problems up right. So again, one of the big things that we talked about last class when we were talking about dividing fractions was what is the mathematical question that you're answering. And that's really the whole key to every one of these problems. Understanding that mathematical question, in other words, which way am I dividing? Because we do not have a commutative property of division. Because I don't have a commutative property of division, if I set the order up wrong, I get the problem wrong. So you got to be really, really careful on this. So our first one, I will say also marking your text is extremely beneficial in these. So Nicole used 3/8 of this ribbon to have a present. If she used 6 feet of ribbon for the present, how much ribbon did she have at first? So our big piece on this is, am I dividing the 6 by the 3/8 or the 3/8 by 6? In other words, which is the part, what's the whole? Is the 6 the part or the whole? There you go. Part, right? Because if why not told us that's the part that you use. So I know that the 6 is the part that I divided out of the whole, the 3/8. Last time when we did whole numbers and fractions, we talked about I have to make that an improper fraction, right? So I can only divide fractions with fractions. But I also don't divide. Instead I multiply by the inverse. So I have to keep, change it to multiplication, flip my second number. So I can reduce by 3, that becomes a 1, this becomes a 2. 2 times 8 is 16, 1 times 1 is 1. 16 divided by 1 just comes out to 16 feet of ribbon, is what you started with. That's wrong. That means you set it up backwards. Okay? Now, this one, actually, a model works really well on this one as well, guys. So it's 3/8. So I draw my K diagram into 8. And I know that 3 of them is how much? 6 feet. So if 3 of it is 6 feet, what is each individual box? Because 3 sevens make 6, right, Gabriel?
Wait, no. 2.
Because 3 twos make 6.
Three times 2.
It's 6? Yeah, so it's 2. So each box gets a 2. And as we learned with our ratio constant, once I have one box, I have all of them. That's why it's a ratio constant. So if every box has a 2, and there are now 8 boxes, what was my total feet of ribbon?
16.
Oh my gosh.
Make sense?
I said 16.
Okay, let's look at number 2. A Boy Scout has 3 meters of rope. He cuts the rope. That's actually important because it tells us about our operation in the cords 3/5 meter long. How many cords will he make?
3 once.
So again, am I dividing the 3 into 3/5 sections or the 3/5 into 3 sections? 3 into 3/5. So I'm taking my 3, dividing it into sections of 3/5. So again, I need to keep and make it an improper fraction. Change the times, flip, 3/5 becomes 5/3. So those go away. 1 times 5 is 5, 1 times 1 is 1. That is 5 chords.
Why'd you cross it out though?
I got it.
I reduced.
How?
Because I have a 3 on top and a 3 on the bottom. So I can divide them both by 3.
Oh, why did I was 5?
What?
I thought it was 5 because the line.
No.
The fraction was 3 off in the fourth place.
So, they can cut 5 chords. Now, this model is a little different. If I were to model this one, I have 3 feet of rope. I'm cutting it into fifths. And now I'm cutting into 3/5 sections, right? So basically for every 3, I add a new chord. So there's 3, there's 3, there's 3, there's 3, and there's 3. I ended up with 5 equal sections. Yes, Genevieve? Not for everyone, but we want you to get used to using it, because it will, especially on these division problems. I'll be honest, division word problems are probably the single hardest ones you're going to do, especially when we throw fractions into it. But division problems in general are really difficult to comprehend when you're translating from English to math. When you throw in fractions, it makes it even worse. And especially as we get down here on number 5 and 6, you'll see having that tape diagram to judge our model off of, and then build our math makes it much, much easier. Yes, Gabriel?
Is there another Gabriel in this class?
No, just you.
Yes!
Nope, so every time I say Gabriel, you're the one I'm talking about. Okay, next one, we've got 12 gallons of water to fill a 3/4 tank to capacity. So this is kind of like our first one. Is this the whole or the part?
Whole. Part.
The part, right? So I got the 12 being divided into the 3/4. So again, I have to keep, so I'm now making a whole number or an improper fraction. Change to times, flip, 4/3. I have one reduction, I can divide both those by 3. 4 times 4 is 16, 1 times 1 is 1, meaning 16 gallon capacity.
Yeah! Correct. Let's go, Mr.
Yeah, my smartboard is acting funny today. Okay, this is actually a really good one for a model, guys. And this model I'm going to do a little differently, because normally when I think of a water tank, I look at it this way. So I'm going to do my model going up. And I know 3/4 of this is 12. So 3/4 of it is 12. What is each section? I have 3 of them, so each one would be 4. So if each of those is 4, what's the last section? 4. So what's the total for the entire tank?
7.
16.
Oh, baby.
Okay?
That's unfortunate.
Now, the tank is filled to capacity. How many half-gallon bottles can be filled with the water in the tank? So now that I've got the 16, I'm dividing it into half-gallon bottles. Correct? So again, to divide by a fraction, instead I'm going to keep, so I'm going to make this an improper fraction, put a 100, change the multiplication, flip, 2 over 1, just have 1s on the bottom, so 16 times 2 gives me 32. So 32 bottles can be filled. Make sense? Our next one is actually another really good one for a model, Genevieve. And this will help you understand what's happening. So Hunter spent 2/3 of his money on a video game before spending half of his remaining money on lunch. If his lunch costs $10, how much money did he have at first? So here's why the model helps us. If I draw this out, 2/3 of his money was spent on the video game. Correct? So that leaves 1 box for me, right? But they said of that box, of that last piece, half of that 1 box was now lunch, or $10. So what's the other half? So that means that the whole box was 20, making my ratio constant 20, meaning the other 2 boxes now get a 20 as well. So 3 20s means I have $60. Okay, so he had $60 at first. Now this one gets a little more complex if you're looking at it strictly mathematically. Because to look at it strictly mathematically, what I have to do is realize I had 2/3, but then I only spent half of the last piece on the lunch, correct? So that $10 was actually how much of his total? It's half of 1/3, which would be 1/6. So 10 divided by the 1/6, which would be my total. Now I do my keep, turn it into an improper fraction, change, flip. 10 times 6 is 60, 1 times 1 is 1, so it's $60. So mathematically, you can do it, but it gets really complex to do it mathematically when they're throwing all the different fraction pieces in there that you've got to keep track of. The model makes it much more clear for you. So I do highly recommend you guys try to practice on these models, get a little more comfortable with them. Our next one, now we look at the students that were surveyed for colors. A fourth preferred red, an eighth preferred blue, 3/5 of the remaining, that's really a key word, preferred green. So 15 students preferred green. How many students were surveyed? So again, if I break this down into a model, it's going to make a lot more sense. So in a model, my denominator is an 8 that I need to take care of. So I'm going to do 8 boxes. We know that of those, a fourth preferred red. So now that it's an 8, how many boxes would be 1/4? 2. So 2 of the boxes are red. 1 of the boxes is blue. And it says, and here's why this is so key about remaining. How many boxes now remain? 5. And it says 3/5 of the remaining. So that means that 3 of those last 5 are greens. Everybody see that one? The other piece of information they gave me is those 3 greens equal to 15 students. Correct? So now my ratio constant, how would I get 15 with those 3 boxes? What does each box need to have? Brooklyn? A 5. And again, with all my ratio constant, I can now place that in every single box. So how many boxes of 5 do I have? 8. Now I heard several of you say, but Mr. Moore, those last 2 are blank. That's basically a conglomeration of all the other students. We had white, black, orange, yellow, basically every color that was not red, blue, or green. Okay? So don't think that just because they're blank they didn't count. They do. They were surveyed. We just weren't told which colors they were told. So 40 students were surveyed. Yeah, not really. I mean, we have classes bigger than that. Yeah, most of our classes all our classes tomorrow are bigger than 40.
Wait, in total?
Total.
What did you say? Oh, that's a lot of
I said tomorrow all our classes are bigger than 40. Okay, Mr. Scruggs got some money for his birthday. He spent 1/5 of it on dog treats, then he divided the remainder equally among his 3 favorite charities. So what fraction of his money did each charity receive? So again, this is where a tape diagram can help us to visualize what's going on. So if I do a tape diagram, it said that 1/5 of his money went to dog treats, right? Meaning how much went to charities? 4/5. And of that 4/5 of his money, how many charities did he divide it among? Does that make sense to everybody? So again, how do I do this? Now I keep my 4/5, change it to multiplication, flip. To flip, I have to have it over 1. Make it an improper fraction. Nothing to reduce, so 4 times 1 is 4. 5 times 3 is 15. So each received 4/15, not tenths.
Oh, I did 15/4.
Yeah, you did it wrong. It's kind of hard for them to get 3 times what he received.
I was going to do the 4/15, I'm like, wait.
Now here's where this one got a little more complex and really threw a lot of people off.
Yes,
He donated $60 to each charity. How much money did he receive for his birthday?
0. 40.
So, how many charities did he have?
3.
3. Each one got $60. So how much money did he donate to charities?
180.
180. So my 4 boxes is $180. Does everybody understand that?
180 divided times 4.
No. 180 divided by 4 will tell me what each box received. So 180 divided by the 4 boxes means it's going to go 4, 5, and I change to 0. So each box gets a 45. What about the dog treat? The ratio constant. It also gets a 45. So now, how much did he spend in total?
45. 140 though.
So he got $245 for his birthday.
Oh, so close.
Apparently not if he can give away everything that he got for his birthday. That's a lucky dog though, $45 just on treats.
Doggo!
Yes, questions on anything on that page?
Yes.
What?
Why do you divide it to multiply it?
Because it's being divided amongst 4 boxes. Not multiplying it by 4 boxes. Because there were 3 charities that got $60 each. Hey guys, please keep it down.
So you divide that.
No.
What?
$3, $60 each. How much money did they get? Each one got 60. How many got that? 3. So it's $180 that went to charities, yes?
That's $180.
Because 3 60s is 180. 60 and 60 and 60. But there's 4 boxes for that $180. Because 4/5 of his money went to those charities. Okay, go ahead and turn to page 16. I'm going to fly through these first ones because they should be easy. Literally, it's just keep, change, flip. 5's go away. 4 times 1 is 4. 1 times 1 is 1. 4 divided by 1 is 4. Same on the next one. Keep, change, flip. 9's go away. 4 and 8 I can divide by 4. 2 times 1 is 2. 1 times 1 is 1. 2 divided by 1 is 2. Next one. Keep, change, flip. 4's go away. 3 and 15 I can divide by 3. 5 times 1 is 5. 1 times 1 is 1. 5 divided by 1 is 5.
And what? I did.
Next one. Keep, change, flip. 5's go away. 14, 3, I can't do anything on that. 13 times 1 is 13. 1 times 4 is 4. 4 goes into 13 3 times with 1 left over.
What? I still don't get number 30.
I don't know what you don't get because it literally works out perfectly fine.
I did 15 and 3, so I did 4.
You didn't keep, change, flip.
Yeah, I did 4 3, 15 and 1. I did 4.
No.
4 and 4 goes to 1. Hey, what?
Okay, next one. Keep, change, flip. 3's go away. 2 and 10 I can divide by 2. 5 times 1 is 5. 1 times 1 is 1. 5 divided by 1 is 5. Keep, 8/5, change, times, flip, 5/3. 5's go away. 8 and 3 I can't do anything. 8 times 1 is 8. 1 times 3 is 3. 3 goes into 8 twice with 2 left over. Last one. This is probably the easiest one you had. Keep, change, flip. So everything reduces. Those are what we call multiplicative inverses. It equals 1.
That was very easy. You just need to multiply one of them and then you just do it.
Yep. Okay, last one. 7/8 miles from the finish line. She can travel 3/8 miles per minute. How long will it take her to finish? So I have 7/8, dividing it into the 3/8. So keep, change, flip. 8 to go away. 7 times 1 is 7. 1 times 3 is 3. 3 goes into 7 2 times with 1 left over. Don't forget your units. Figure 2 1/3 minutes. The model on this one really isn't that bad. If I do Yeah, 2 minutes, 20 seconds would be fine, because a third of a minute is 20 seconds. So if I did this, I'm looking at 7/8 that I'm dividing up. I'm dividing into 3/8 sections. So how many do I get? I get 1, 2, and then I get 1 of the next set of 3. So 2 and 1/3. Make sense? So some of these, the models are more helpful than others, I'll be honest. Next one, he has 4.1 centimeters of wire. How many strips of 7 centimeters long can he cut? There's our question. Big problem on this one, they gave me a decimal and a fraction. Can I do those straight off as a decimal and a fraction?
Yes, sir.
No, I have to have the same format. So I have two choices. I can make that a decimal or just a fraction. Since we're dealing with fractions right now, I'm going to go that way. So I can rewrite 4 and 1/10 as 4 and 1/10. And I'm dividing it into 7/10 sections, correct? So first off, we're going to start with our slam dunk. So that gives us 41/10 divided by 7/10. Don't forget, once you've got slam dunk, you still have to do keep, change, flip. So now I go keep, 41/10, change the times, flip, 10/7. 10s go away. 41 times 1 is 41. 7 times 1 is 7. 7 goes into 41 5 times with 6 left over. So our question was, how many strips can he cut? He can cut 5. How much is left over? 6/7 of a strip. Okay? Can't use the units. I'd have to do a whole other conversion to make that into meters. But that gives you the general idea. Okay, and that's what it's about to start. So I'm going to go over your homework and then I'll come back to do this if we have time after the announcements. So everybody turn really quickly to page 35. Remember that you're in section 6.2. So on the top of your page, it should say 6.2. If you're in 6.1 or 6.3, that is not the correct homework. So 6.2 on the top, you're going to go down on the bottom, it says page 35. We only want you to do the first 3 problems. You do need to do all 3 on each, so that's actually 9. But we're going to let you cut out all the word problems. We practiced those in class today. We're not going to make you do any more word problems, okay? So cross those 4 out. Oh, wow, look, Noah's actually paying attention.
When you're from the canal.
Well done, Noah. Okay, now we will cross that out. Go ahead and turn to page 38. I know. Honestly, the homework is a big part for the recording. So, page 38, there's only 4 problems, guys. So, quite frankly, I mean, it's 16 total problems. I would be surprised if many of you take more than 10 minutes. Because these are the harder ones and these aren't hard. Just remember, mixed numbers, I have to slam dunk, and then I do keep, change, flip. Please don't forget, keep, change, flip after you do that. Okay, that being said, let's go back to our last page, page 16, these last couple. 16.
Yes. It's not adding 13. It's 3 times 3 on one page and 4 on the other, right?
3 times?
3 is 9.
Oh, I thought there was 40. It's 3 on each?
Yeah.
Yeah, so 13 total problems.
Okay, I thought I was right.
Oh, that's beside the point. Okay, so you bought 20.5 pounds of ground beef. You use a 4 thirds beef to make tacos, 2/3 of the remainder to make 1/4 pound burgers. How many burgers did he make? So take diagram again will help us to build all this out. So it's a 1/4 of the beef to make tacos. So a 1/4 of it was tacos, 2/3 of the remainder. So here's our remainder. 2 of those 3 are hamburgers. So of the total hamburger, how much did he actually use for the patty? 2 of the 4, or half of it, correct? So if I take the 21.5 and I divide it by 2, We have to do our slam dunks. He goes 43 halves. Then I keep, change, flip, so 2 over 1 becomes 1 half. I did it again. I don't know why. That's a 2 there, not a 1. Nothing I can reduce. That gives us 43 fourths that is being used for the hamburger patties. What is he doing to the hamburger to make the patties? He's dividing it into quarter-pound burgers. So dividing this into quarter-pound burgers, yes? So 43 fourths, keep, change, the times, flip, fourths becomes 4 over 1. 4 is reduced out, 43 times 1 is 43, 1 times 1 is 1. So he made 43 hamburgers. Then our last one. A baker bought some flour. He used 2/5 of the flour to make bread and used the rest to make batches of muffins. We used 16 pounds of flour making bread, 2/3 pounds for each batch of muffins. How many batches of muffins did he make? So again, a tape diagram can help us to organize our thoughts in this. I have 2/5 of it was for bread. That's 16 pounds. So if this is 16 pounds, what's my ratio constant? What goes in each? 8 for my ratio constant. That means I have 24 pounds of flour that I use for the biscuits. So my 24 is being divided into 2/3 for each of the batches. So again, we do our keep, change, flip. I got 2 and 24. I can reduce that out by 2. 12 times 3 gives me 36 batches of muffins. Make sense, guys? Okay, if you didn't get any of those, take the time to practice at home. Remember, you have a quiz next class, okay? Quiz for a grade.